I'm Anil Kumar. In this video, we will learn all about powers, how to represent them, and how to calculate the numbers with exponents. So we'll look into numbers like this, 3 to the power of, let's say, 4, right? So if you see a number which is written like this, we say 3 to the power of 4, you can read this as 3 to the power of 4, right? Now this is a short way of writing numbers like 3 times 3 times 3 times 3. So if I say 3 to the power of 4, it really means 3 times 3 times 3 times 3, 3 times itself 4 times. Do you understand? So here we have shown you a number in the form of a power which is written as a repeated multiplication. So that was my first point. So you could write a number as a repeated multiplication in the form of a power. So that is kind of a shortcut, right? So it is a shortcut to represent numbers. So in this example, you saw that we have written 3 times 3 times 3 times 3 as equal to 3 to the power of 4. So that is called a number in the form with powers. Now this is so common that we always use them. So we have different names. We call this number on the top as exponent. And the number here as base. So if I write 5 to the power of 3, it really means that we need to multiply 5 by 5 by 5, so 3 times. And you can calculate 5 times 5 is 25, times 5 is 125. So that is how you can evaluate your powers, right? So I hope that gives you some exposure to the topic which we are going to discuss. If I write a number, let's say 2 to the power of 10, in that case, we know that the base is what? And what is the exponent? We know clearly that the base here is 2. That is the base. Base is 2 and the exponent is 10. Now if you want to evaluate, so when we say calculate this number, in that case you can multiply 2 by itself 10 times. So you'll find then 2 to the power of 10 is equal to a very big number, but which is very close to 1000, 1024. So to get this, you'll have to do 2 times 2 times 2 times 2. There should be 10 2's when multiplied. So you can see how easy or convenient it is to express in the power form. So that's the whole idea. So it is ease of expressing big numbers. So these are few advantages of writing numbers in the form of power. Now by these examples, I think you have understood the concept that power is treated as a repeated multiplication, and you can now identify base and exponents if I give you something in power. And you also see that how multiplication and power are related. Now here is a question for you, and I'll introduce you to 2 more terms, and the question is, which is greater? Two cube or 3 square? So that is a test question for you. Try it out. Now, as you saw, when I wrote this, I introduced you to two more terms, and these terms were cube and square, right? So here are two more terms which are commonly used. We call them cube and square. So cube is when exponent is 3. And square is when exponent is 2. Okay, so that is the basics about power which you should know. And now we are going to move on to laws of exponent and see what happens when we multiply and divide numbers with powers, right? So that is a critical part which we are going to learn now. So we kind of call it laws of exponents. We'll take very simple examples to figure out these laws. So first one, what happens when we multiply? So what I'm trying to say is, let's take two numbers. If I say 2 to the power of 3, that is 2 cubed, times 2 to the power of, let's say square, let's keep it simple. What is that equal to? Well, 2 to the power of 3 means we have to multiply 2 by itself and we should have 3 2's. And then 2 square means there are 2 2's which are getting multiplied. Now, that is repeated multiplication, correct? So I could write this as again as power, where the base is 2 and the exponent is 1, 2, 3, 4, 5. Do you see that part? Now the easy way to get this is 2. You could add these power, 3 and 2. You get the same answer. You get an idea. So basically, when you multiply numbers with exponents, the exponents get added up. Correct? So let's do some examples. If I write 3 to the power of 5 times 3 to the power of 7, it should be equal to 3 to the power of 5 plus 7, which is 3 to the power of 12. Does it make sense to you? So when you multiply, the powers get added. So that is our first rule. Right? Okay. Now what happens when you divide? Let's check that. What happens when you divide? Okay. So let's do this. 2 to the power of 7 divided by 2 to the power of, let's say 3. So that really means 2 to the power of 7 means 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. Divided by 2 cube means 3 2's. Now, 2 divided by 2 is 1, 2 divided by 2 is 1, 2 divided by 2 is 1. So when you simplify, what you get? You have 1, 2, 3, 4, base is 2, exponent is 4. Perfect. Now I could have got this answer by taking away 3 from 7. So it is also 7 minus 3. Do you see that? So when you divide, the exponents get subtracted. So that's the second rule. Let's take an example. If I write 5 to the power of 6 divided by 5 to the power of 3, I should get 5 to the power of 6 minus 3, which is 5 to the power of 3. You can of course evaluate them, but at present we'll just work up to this place. So what we get here is two very important rules of multiplying and dividing exponents. We could also have power of power. Let me write down the next rule, power of power. To give you an example, what I'm trying to say here is something like this. If I have 3 here, let's say 3 square, and I go to its cube, so that is like power of power. Now, how do we understand that? 3 square basically means 3 times 3. And we still have a cube. Now, this cube means both these 3 times. So, it should like this. 3 times 3. Then again, we know we have to put it 3 times. All this. 3 times 3. And then again, 3 times 3. How many 3's do you have? 1, 2, 3, 4, 5, 6. So, it is 3 times 3, where 3 is repeated 6 times. So, it should be 3 to the power of 6. Well, now can you guess what kind of rule we applied? Well, in this case, we multiplied 2 and 3 to get 6. You get an idea, right? So we could write this rule as if I have 3 to the power of 2 to the power of 3, it should be equals to 3 to the power of 2 times 3, which is 3 to the power of 6. Now for you, here is your test question. So you need to evaluate the following. So evaluate after writing as single power. So when I say that, I mean this. You wrote as a single power, right? There were 2 terms. You wrote as a single power. Again, you wrote as a single power. That is as a single power. This is what I'm trying to say, correct? So evaluate after writing as single power. So evaluate means calculate. Okay. So let me give you a few questions here. A. What is 2 to the power of 3 times 2 to the power of 7? B. 3 to the power of 4 minus or divided by 3 to the power of 3. C. What is 5 to the power of 2 to the power of 3 equals to? Correct? So write them as a single power and then evaluate. Correct? Now let us also learn how to calculate using calculator, right? So till now we did without calculator. Now we'll see how to evaluate using calculator. So let me first give you the answers for these questions. So 2 to the power of 3 times 2 to the power of 7 should be what? So it's like multiplication. You'll add these powers. 7 plus 3 is 10. Now the next one is 3 to the power of 4 plus 4 minus 3. Since it is divide, 4 minus 3 is 1. So whenever it is just 1, write it the number 3 itself. Anyway, we'll get back to this. Now when you have power of power, they get multiplied. So we get 5 to the power of 3 times 2, 6. So that is writing these expressions as single power. Now let us see how to evaluate. Now to evaluate on the calculator, you have the function this x to the power of something. Do you see that? X to the power of something. Now that can be utilized. So let's do 2 to the power of 10. So 2 and then press this and write down the number, right? And then we have to check the answer. So we get the answer as equal to 1024. Do you see that? So that is how you calculate using calculator. Now anything to the power of 1 is the number itself. So I'm writing direct answer as 3. But we'll move on to 5 to the power of 6. 5 to the power of 6 is equal to a very big number, which is 15625. So now you also learn how to use calculator to calculate the answer for such big numbers. Now let's move on and learn about more laws of exponents. And now this time we'll discuss about powers when exponents are (1, 0 or -1). So that is what we are going to look into. So how can we get these exponents? Well, sometimes when we divide, for example, let me take some example. If I have 5 to the power of 6 divided by 5 to the power of 5, what do we get? How about 7 to the power of 3 over 7 to the power of 3? What should I get? And what happens when I write 2 to the power of 5 divided by 2 to the power of 6? Now let's try to use our laws and figure this out. So when it is divide, you subtract the exponents. What you get here is 5 to the power of 6 minus 5, which is 5 to the power of 1. Now 5 to the power of 1 is 5. How are we sure? How are we sure? Now let's answer this question. What you could also do is you could write 5 to the power of 6 in the numerator. That means 5 times 5 times 5. So we got 3 5s. Now 4th, 5th and 6th divided by 5 to the power of 5. 5 times 5 times 5 times 5 times 5. Now you could simplify by crossing out common numbers. Do you see that? What are you left with? You're left with just 1 5. So 5 to the power of 1 should be equal to 5. Does it make sense to you? So that gives us a rule, and that is anything to the power of 1 is the number itself. So if I have a to the power of 1, it should be equal to a. Anything to the power of 1 is the number itself. Okay. So that's the first rule we learned about exponents 1, 0 and minus 1. Now what happens here? Well, we are dividing 7 to the power of 3 by 7 to the power of 3, and obviously the answer is 1. Correct. If I apply the rules, what do I get? I get 7 to the power of 3 minus 3, which is 7 to the power of 0. So that gives you an idea. Anything to the power of 0 is 1. So the rule here is anything to the power of 0 is equal to 1. The last example here is 2 to the power of 5 divided by 2 to the power of 6. So if I apply the rule, what do I get? I get 2 to the power of 5 minus 6, which is 2 to the power of minus 1. Oh my God. How do I calculate this? Let's try. So we'll write 5 2's in the numerator and divide by 6 2's. And let's try to cancel the common factors. So we do this. What are we left with? We are left with 1 over 2. So therefore, 2 to the power of minus 1 should be equal to what? 1 over 2. Do you get an idea? So that really means that if I have a to the power of minus 1, it is basically 1 over a. Is that correct? So these are 3 more laws. That anything to the power of 1 is the same number. And if the exponent is 0, what you get is 1. But if exponent is minus 1, what you get is reciprocal. So this is reciprocal of the number. Is that clear? So these are very important laws which can be applied to calculate and to understand the numbers. I hope you are finding it interesting. Let's move on and check some more. Now, here are a few practice questions for you. So let me call them as examples. So I'll give you a few examples. You need to copy them and then write their answers. So if I have 5 to the power of 0, what is this equal to? 1 to the power of 0, what is this equals to? 3 to the power of 0, what is this equal to? If I have 7 to the power of 1, what should that be equal to? If I write 6 to the power of minus 1, not 1, then what is that equal to? And how about 5 to the power of minus 1? And if I give you just general terms, that is a to the power of 1, what is that equal to? B to the power of 0 is what? And c to the power of minus 1 is what? Right? So what you have learned here is three things. And these three things are anything to the power of 1 is the same thing. Let me put in other words, a number we're talking about with exponent of 0 is 1. Now here there is one exclusion, and that is when number is not equal to 0 itself. Is it okay? Now 0 over 0 is not defined, so we'll take that as a separate case. And the last thing which we learn is exponent of minus 1 gives a reciprocal number. Okay, so in all our examples, we are excluding 0, right? So we're talking about numbers excluding 0 for the time being. That is kind of important, right? So I wrote in three different ways what we have learned. A very general way, anything to the power of 1 is the same thing. It's not very true to write like this. Slightly more technical, a number with exponent of 0 is 1, and then exponent of minus 1 gives a reciprocal number. So I hope this concept is clear, right? And you can always write the answers for this, which are clearly anything to the power of 0 is 1. That's what we have learned. If the power is 1, then the number is the number itself. In this case, it will be a. But if the power is minus 1, we expect reciprocal. That is what I mean, 1 over this number. In general, b to the power of 0 should be 1 and c to the power of minus 1 will be 1 over c. Does it make sense to you, right? So with that, let's move forward. So I hope you have understood it completely. Now here is a very important question for you. Is power of a number greater than number? So the answer is not always. Can you give me examples? Now this is a question for you. So what you learned so far? You learned that 2 square is 4, and you know 4 is greater than 2, correct? You learned 3 square is 9, and you know 9 is greater than 3. But here are some examples which will make you think. If I write decimal numbers 0.1 square, then it is what? It is 0.1 times 0.1, and if you multiply, you actually get 1 after 2 decimal places. It is 0.01, correct? Now what do you notice here? You notice that the exponent is not greater. So the number 4 was greater than 2, but in this case 0.01 is actually not greater than 0.1. In fact, it is less, right? So in fact, what we see here is that 0.1 is greater than 0.01. Do you get the idea? Now let me give you another example, and let's take a number half. So if I have half to the power of 3, what do I get? I get half times half times half, which is 1 over 2 times 2, 4, 4 times 2, 8. Which is greater? Which is greater? Half or 8? We know clearly that half is much, much greater than 1 out of 8. Correct? So, is power of a number greater than number? Not always. So, there are many cases when it is not greater, especially when you have a number which is between 0 and 1. So, if you have a number between 0 and 1, then the power is smaller, right? Now, here is one unique example when it could be same also. So, in this case, what we learn is power is smaller than the number. But if I take 1, so 1 to the power of anything, let's say 5, is just 1, so both are equal. So we know 1 is equal to 1. So they could be same also. So here we have all the three conditions. It could be greater, it could be same, or it could be lesser. So all the three conditions are possible with powers. And these are the examples. Now here is the practice test for you. I would like you to copy these questions. They're all to the powers of 1, 0 and minus 1. So write down their answers. Correct? Now I will add some more questions based on the rules which we learned. So you need to evaluate three square times 3 to the power of 4 equals 2. You can use calculator after simplifying them, right? So 2 to the power of 3 divided by 2 to the power of 4 equals 2. 3 to the power of 7 divided by 3 to the power of 4 equals 2. 5 to the power of 2 to the power of 3 equals 2. 6 to the power of 3 to the power of 0 equals 2. Correct? So you can evaluate these terms, write down your answers. Here are the solutions. So anything to the power of 0 is just 1. This is 1 over 5 and this is 3. The number itself, anything to the power of 0 is 1. This is 1 over 2. And 1 to the power of anything is always 1. You could write in decimal numbers if you want to, but it is not necessary. Correct? So that is your choice. You could write this as 0.2. This is 0.5. Which is greater? That is a very important question for you, right? So the last question here is, which is greater? Five to the power of minus 1 or 10 to the power of minus 1. Okay, so that is your last question. So we have three categories of questions for you. Here you're going to add the powers and then evaluate. So it is 6, 2 to the power of, when you divide, minus 1, and here you'll take away 3 to the power of 3. Here you're going to multiply 3 times 2 as 6, and here anything to the power of 0 is just 1. Correct? So you should write, first you should write this as 6 to the power of 0, 3 times 0, and then 1. So I hope that gives you a good review of what we have learned about powers. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.